Hello, Dan here. Here's my attempt at recreating the Lightcycle from the original Tron film. Tron was one of the first films to use computer graphics, and the Lightcycle sequence is for me one of the highlights. Produced with CSG, Constructive Solid Geometry, rather than polygons as used on other sequences, the Lightcycle was made by adding and subtracting geometric primitives to form more complex shapes. The cool thing about this is that it can create very nice smooth geometry that would have been very difficult to do with polygons back then. It would be simple to recreate the Lightcycle in modern software, but I thought it would be interesting to try to do it the old school way with CSG primitives only. This led me to revisit an old piece of software that's still around and would be perfect for the job, that is POV-Ray. POV-Ray, Persistence Vision Ray Tracer, came out in 1991 and was ported to many computer systems, including the Atari ST, which is how I first encountered it when it was featured on a magazine cover disc in 1993. Rather than manipulate shapes on screen, you had to write a scene file that describes the objects, lights and camera that you want, then run the renderer and hope for the best. It was often a long wait, as even fairly simple scenes could take hours on those old computers. Thankfully things are a lot faster now, which makes it a lot more fun to experiment. Here's a walkthrough of how I created this Lightcycle animation. So here's the scene file for the Tron cycle. If I push run, there's a result. Now, you probably can't see this particularly clearly, so I'm going to go to editor and I'm going to change the text size up so that it's a bit more visible on the video. Okay, so this is the scene file, and I'm going to recreate this and explain each part as we go, and I'm going to do that in a Tron cycle new. Now, we're going to begin with these parts, which I've copied from this one. I'm going to add a few extra things as well as we go, that improvements that I've made. So the first thing we do is we set a version. Now in POV-Ray you want to use the current version, which is 3.7. If you don't specify this, it's probably not going to make much difference in this scene, but there are certain features that POV-Ray has that may not work if you don't define that, because if you leave that out, it assumes you're using a legacy piece of code, and certain things get switched off to keep compatibility. So we'll put that in. We also have to add in a global settings area an assumed gamma of 1. That just says to POV-Ray to use linear color space. This isn't to do with display gamma, which is controlled separately somewhere else. So we've brought in 3 include files. So we've got shapes.inc, shapes2.inc and colors.inc. Now, include files are just ways of bringing in code from another file into your current file without having to see it all like you would if you cut and paste it. It keeps it all nice and neat, and I would edit these and add new ones and stuff. It's best to leave them as they are though here, so that you don't break compatibility. I would start new ones rather than edit these. And we can see what's in these by going up to Insert, and in this menu we can look in Shapes 2 and we can see that's what Y box is, round box. We get to see all the different ones that you can use, and then Colors displays the different colours that have been predefined. Now we're also going to define our own colours down here, which I'll look at in a minute. But the first thing we need to do is add a camera. Now I've already set the camera up for the final render, and that just puts it in a nice angled position so we can look down and to the side. And we've added 2 lights. Now before I talk about lights, I'll keep talking about the camera a little bit more. So when you bring a camera in, you type camera and then you have these curly brackets, and you have to put a location, and then the coordinates go inside these angled brackets. Then we have look at, which is a point in world space that the camera's aimed at. Now light source, if you just do a light source like this, it's a standard point light. And we again define the location using these angle brackets, and then we type color, and then we can add a color here. Now I've used white, which is defined in colors.inc. I also added a second light. This time I colored it using the components red, green and blue. So let's say I wanted to have my bike, and I suddenly realized I want it to be red instead of yellow or blue or something. There's going to be quite a lot of color statements, so rather than change the colour on every single piece, it's useful to just define a material here like LC grey. This is Lightcycle grey, Lightcycle main, Lightcycle shiny black, and we can then change this. So if I wanted to change the main colour, I could just change this from orange to red or whatever. So to declare something, it's hash declare, then the name you want to give that definition, equals, and then the actual definition that you want, and then you put a semicolon at the end. So before we start placing objects, let's just have a quick look at the render. Now you can see that it's created out of a sphere here, and then there's a sphere that's been used to cut a hole in this. Then we've got rounded cylinders which have been cut to form this piece, and we've got cones here. We've got another rounded piece here which has been sliced into a thin strip, and we're using a gradient here to create this effect. So let's start with the wheel. So the first thing we need is a sphere. To add a sphere, it's simple. You just type sphere, and you do the curly brackets, and then we put in the location that we want the sphere in, and that has to go in the angled brackets. And then we put in a radius for the sphere, and in this case we're going to use 0.5, and the location is going to be 0, 0, 0, so it's right in the centre. Now we also want to colour this, so we put in texture, pigment, this goes in curly brackets, pigment, and then curly brackets again, colour, and then we type in the colour we want. Now in this case we're going to use LC main, that's the one I defined just here. So let's just drop that down to there. Now if I render this by pushing the run button, we just change that so that it saves it. There we can see our first sphere. So I want to chop this down. So what we're going to do that, there's two ways. We could put two boxes and do a subtract, or we can have one big box and do an intersection, so we get to keep the bits that are inside the box but get rid of the bits that stick out. That's the way I'm going to do it. So let's bring a box in. Let me just close that. Box, open and close, curly brackets. Now in boxes you define the corner points that are opposite to each other. So in this case it's going to be minus 0.5, minus 0.5, and then minus 0.345. And then the next corner is going to be the opposite, so it's going to be plus 0.5, 0.5, 0.345. Now we need the same colour statement so that we don't get any weird different coloured faces appearing. So let's do that, and let's just run that. Okay, so you can see how we've got the box and the sphere sticking out, and these are the bits we want to get rid of that's sticking out. So to do this we're going to use intersection. This is part of the CSG, the Constructive Solid Geometry process. So we go here and we type intersection, open curly bracket, and then close curly bracket at the end. So everything inside here is going to be in this intersection operation. So if I run that, you can see that it's trimmed that off. Now I also need to cut a round sort of concave area into this, like a scoop, and we're going to do that with two more spheres. So we're actually going to use the same sphere here, but then just make it a bit smaller, 0.49. And I'm also going to translate it. So we do that by typing translate, and then we can move it by, we don't need to move it on X or Y, so it's 0, 0, and then we'll do 0.67 on Z and close it with our our angle bracket. So if we take a look at that, you can see we've got that sphere there, and we need another one. And this time we need to be minus 0.67. Okay, so now we need to subtract these. So to do that, we need to add difference at the top. Difference, open curly bracket, close curly bracket, run that, and you can see we've cut a round shape into this. The next thing I want is a black part in the center. So to do that, I'm going to add a cylinder. Now cylinders have the keyword cylinder, and on a cylinder you set the bottom, the center of the bottom and the center of the top. So we need two things, and we need a radius as well. So the bottom of our cylinder is going to be at 0, 0, minus 1, and the other end is going to be 0, 0, plus 1, and I'm going to give it a radius of 0.3. Now if I run that now, you can see our cylinder, but it's black. So let's give it some colour, just so that we can see it, so I can show you what's actually going on. So just put texture in, pigment, colour, we'll use white. Let's have a look at that. Good, so you can see what's going on there. Now I need to cut this by the same spheres that we used to cut the piece here. So I'm going to just copy those. And put them down underneath. And I want all these to be black. So what I'm going to do is change that to black, that to black, that to black, and we're going to do a difference because we need to subtract these spheres from this cylinder. So we need difference, and then we put that in inside those. Let's take a look at that. And that's what we get. You can see there's some weird things happening here, and that's because there's an overlap. So what we need to do, we can either move one of those spheres, or we can, what I'd like to do is just put a scale in. So I'm going to put scale, and then we use our angle brackets, 1, 1, because we don't want to change it on X and Y, but we'll change it on Z by 1.05. So if we look at that, okay, that's what we get. Now this looks a bit bland, so I want to add some shininess to it. The black parts on the Tron bikes do look quite shiny sometimes. So we're going to have an extra thing here at the end. It's going to be called finish. So we type finish in, and then open and close brackets. And I've defined at the top LC shiny black as my finish setting. So let's put that in there. Now if we run this, you can see we've got some shininess going on there. Right. So the next thing I want to do is just join all these up. So you don't technically have to do this, but I think it's neat. So if we type union and then close that off at the bottom, that'll give us just the, that's just one piece now. Now, we obviously need another one of these for the back wheel, and we need to shrink it down. Now I could cut and paste all of this, but there's a better way, and that is to use declare again. So what we can actually do is we can declare this, all this as a single piece, as a wheel object. Let's just actually do some comments first so that this is a bit clearer to see. I'm going to just call this wheel base. Now to comment stuff out, you just use 2 of those forward slashes. You can do, if you do /*, it'll comment out everything in between that and the other one. So if we do another one at the bottom, I can't get it right. So anything inside this gets green as well. It basically means that the POV-Ray doesn't read that, but it just ignores the comments. It's for us so that we can see what we're doing. This is in most programming languages. Okay, so we want to declare this. So I'm going to use hash again and declare. I'm going to call it wheel, type equals, and that's all you have to do. That is now taking all of this, and it's now, I don't need a bracket. If I run it, you can see it's disappeared. That's because all of this has now been absorbed into this wheel statement. So to get it back, what I need to do is go here, and I'm going to type front wheel just as a comment so I can see what I'm doing, and then you use the term object, open curly brackets, wheel. Now if I run that, you can see our wheel comes back. So now what I want to do is bring out the well, before I do that, let's just translate this up, because at the moment this is sitting below the ground plane, although we can't see the ground plane at this point. But what I'm going to do is translate this. So to do that, we just go inside that curly bracket and we type translate, and then 0 and 0.5, because our radius was 0.5 if you remember, and then 0, and that'll just bring it up. So now what we need to do is do the rear wheel. So let's just put comment in. So we type object, wheel, translate. I'm going to move this 2.5 on X, 0.5 on Y, and nothing on 0. I mean 0, nothing on Z. Okay. I'm also going to scale it. So if we do scale, and I'm just going to scale it on the Z, so it's 1, 1, and then 0.22 is a good number. So I now close my bracket. Let's take a look at that. You can see we've got the rear wheel now. The last thing I'm going to do on the wheel at this point is just to add those little spheres there. So let's just do that. So that's just 2 more spheres. So we'll do I'll call it axle. We'll do one for the rear as well. So I'm just going to paste this in from my other file. That's just spheres, and we're using that LC grey that we defined at the top. So if we run that, we've got those now. Okay, so now let's work on the engine part. Let's start a new section. Whoops. Engine. So for this, we're going to begin by making this part, which is obviously a cone, and we do have a cone primitive. So let's put that in. Cone, open and close curly bracket, and then we need two of the ends. Just like the cylinder, you have to define the two ends and what the centre is of those ends. And in this case, I'm going to use a value of 0.375, value of 0.5 on the Y and 0 on Z. Now the other side is going to be 1.2, 0.5 and 0. And then we set a radius on this. So this first piece, which is this end, we set the radius there of 0.35, and then the other radius is 0. Now you don't actually have to put these commas in, but I think it's easier to read if you do. So just to recap this is like the bottom of the cone, and this is the top of the cone. Or if in this case, because we're going horizontally, it's the left side and the right side. And this number is the radius at that side. So that starts off at 0.35 and goes down to 0 at the other end. So let's do our texture. Pigment. Colour, and we're going to use the LC grey that we predefined. And let's take a look at that. I'll put one or too many of those in. There we go. So there's the cone. We now need the box part. So we've already discussed how you do boxes, so I'm just going to paste that in from here. Okay, that gives us that. And I also want a box that goes up here at an angle. If we go back to our image, you can see that's going up there. You'll notice that this has like a rounded edge. Now there aren't any rounded edge primitives as such, but there are macros which do the rounded edge for us. And how they work is they put a sphere at the corners and then a cylinder along, and then you can choose to merge it all into one piece. So to do that, this is where we have to have the shapes2.inc loaded. Okay. So to bring in one of these macro objects, we use the command object, and then we type the name of the macro in, and in this case it's round with a capital R, round underscore capital B box. And then brackets, and then we need to use those angle brackets again. And what we need is 0.6 on X, 0 and minus 0.125 on Z. And then the other end is going to be 0.5, 0.5, 0.125. Now there's two more parameters we need for the round box. Actually, I have made a mistake here. The brackets on the macro objects have to be the round brackets, not the curly ones. So let me just fix that. Now we need 2 more parameters inside this. Now the first one is the radius of the rounded edge that we want to create. So that's going to be 0.05 in this case, and then comma, and then we just type yes. That just instructs it to merge those extra pieces into so it forms one solid piece. Okay, so we'll go down here and we'll add in our texture piece again. And we're also going to add in a rotation and translation. Now it's important to note that when you do a rotation in POV-Ray, it's always going to rotate around the center of the world. Now this is why you don't want to move your part in place and then rotate it. You need to rotate it first and then move it. So we're rotating it by 25 degrees and then we're translating it into position. So let's take a look at that. Need to get rid of that. There we go. So that's now given us that. I also want to add those cones in. So let's do that next. So we want cone again. In fact, I'll just paste this in because we don't need to explain everything every time. So let's just paste this in. So let's put that there. There's actually one on the other side as well. So to do that, I just duplicated it and moved it. That one's negative 0.1 in Z and that one's positive 0.1 in Z. So that's that one done. And now we need a couple more. So let's look at that. And that's given us that one. Now what I've done is, as you can see, I've rotated these because I wanted this edge to be parallel with that and this edge to be parallel with that. But that means this is no longer flat. I'd like that to be perfectly vertical. So I'm going to chop it, and I'm going to do that with a box. So let's add a box. Let's just to make this a bit clearer, I'm going to put that there and do little exhaust cones, back exhaust cones. So you'll see why in a minute. So I need to add a box now. So we know that to add a box is fairly straightforward. It's just box, and then we define the corners. So if we take a look at that, we've got this box. Now it doesn't matter how big the box is because we're just using it to cut, and as soon as we do our cut operation, it's going to go away. So I just, you just do it so that it encapsulates what you want to achieve. Let's hide that. Now this needs to be cut on this cone, or both of these cones. So we're going to add difference here. Difference, open that, and then look at this. So that has now chopped that down. Now we need to do the same thing on this end, so let me get rid of that. Now before I do that, I'd like this all to be one piece. So I'm going to go up to the top where my engine starts. I'm going to type union, open bracket, and then close bracket there. Let's just hide that. Okay, so now I need another box, because what I'm going to do now is subtract this area. I just want to chop that down. There's actually a few operations I want to do here. I want to have a cylinder here to cut this out, to create a hole for this sphere to stick out. And also, you can't see it from this angle, but the wheel is actually intersecting with this body part of the bike. So I need to cut a cylinder out for that. So we'll do that bit first. Let's grab a cylinder. We've already talked about cylinders, so I'll just paste this one in. So if we look at that, whoops, I need an extra one of those. Okay, that should do it. Okay, so we've got a cylinder in there, which I'm going to subtract from all this. I'm also going to have a cylinder to cut that hole out, so I need another one. Let's stick that in just there underneath. Okay, and then finally I need the box. So paste that in. So we've got this great big box. So now what we need to do is subtract all of these from this. So we go up to the top where our engine starts, type difference in just here. Open bracket, go down to the bottom, close it, and then run. And that's now created that part. So next we're going to work on the canopy part. So we're using these rounded cylinders, which work in a similar way to the rounded box, in that there's some sort of sphere that's being moved along here. It's a macro. So we're going to have, if you can imagine, a cylinder that goes all the way around here, and then we're going to cut bottom off there. We're going to cut a shape here and here, here and here. So we need a few boxes to chop this up, and then we're going to have another cylinder here, which we add on to the top to create this part. Okay, so let's do that. Let's start a new section. Canopy. So this is, as I said, a macro. So again, we use the object function. So we bring that in and then open that up, and we use round for capital R underscore capital C cylinder. And we use the round brackets again. So in here, I'm going to add let's just check that. Okay, so that's created that big piece, and we're going to cut it here and do some things here. But let me just explain this a little bit further. So round cylinder works much the same as the other cylinder. You define the bottom of the cylinder, center point, then the top, and then you do the radius of the cylinder, and then this number is the radius of our rounded edge, and then yes to merge it in. Now we need to change this from orange to LC main. Okay, that's better. So I've scaled it and translated it. We need to add, we need to add the box now, which we're going to use to subtract the bottom. So let's bring that in. In fact, now before I do that, I'm going to add a second rounded cylinder. So let's put that in. So now we've got the extra bit there, which is the sort of bit that pokes out the top. Now we can do the subtraction along the bottom, which we use the box for. So I'm going to grab my box. Let's stick that here. We also need to change these all to LC main. let's look at that. We need another one. There we go. Right, so that box is there. We're going to use that to cut this off. And we're going to also do a few more. So I'm actually going to grab from my file the other ones, and I'm going to paste these in. Just to save time. So there's quite a few different boxes there that we're going to use to do the intersection, or rather the cutting. Let's change these. Okay, that looks about right. We also need some more up here, and to do that I use the rhomboid. Now that's another one of those macro objects, so let's go here and bring that in. Pop that in at the bottom. There's two of them. We'll change that to LC main. So that's brought those in to cut that piece out. So these will need to be subtracted. So what we're going to do, before we do the subtraction, we're going to do a union. So let's do union, because I want to glue these cylinders together, these rounded cylinders. So we'll put that there. So that's like that, and then we can call that cutters. Okay, so now all I need to do is put difference in. So if we type difference in there, and then go to the end, run that, you can see we've created that shape. So now I'm going to add the windows, and I'm going to just cut and paste this in because it's just the same thing that we've been doing. Just going to paste that in. We can fiddle with this a little bit. Instead of that, I'm going to put in my LC shiny. Is that what I called it? What did I call it? LC shiny black. LC shiny black. Do we need any more? Yeah, there's another one there. Put that in there. Okay, so this is another sphere, scaled and translated, and then a box, another box to cut it to form that shape of that window. And then the top window is an intersection with another round cylinder and a box to cut it. So if we run that, we're getting these bits now. Let's put that at 0, and we'll call that one, we'll colour that one blue. Okay, and I'm going to glue those together with a union. Okay, so you might remember that we can move these whole pieces if we put the translate inside here. So if we go 0.5, 1.4, 0, 0, it transforms the whole union. Now what I'm going to do is I'm going to change the colour. So I'm going to type texture, pigment, colour green. Nothing happens. And that is because when you specify the texture here, it does not override what you've got at the top. Once you've given it a pigment here, it doesn't get overwritten. So what we're going to do is we're going to get rid of these. And now if we run it, it works, which is fine. So that seems okay, but the problem comes when you are setting your scene up. So if we get rid of this, and if I run that, obviously when you don't put any colour on these objects, they're black, and they're completely black with no shading. So if I was to change the background, so if I go here and do background colour, make it white, run that, what we get isn't a very good representation of the geometry because it's just completely black, like a black hole. So that's why I like to put at the top a default in. So I'm going to add default pigment color. I'm going to use grey. And now when we run it, you can see what's going on without having to add any colours onto the pieces you're working with down here. Okay, we'll get rid of all this and start on the light trail. So you may find a better way to do this. This is the way I did it. We begin by a round box. I'm going to cut and paste this in. So we rotated it and scaled it, and that gives us this. I would like to slice this now, so that we've just got a thin cross section. So to do that, we need a box. So I'm going to grab another box and paste that in. Okay, so it's a very thin box, but we need to create an intersection now between these two. So we put our intersection command at the top. Okay, that's created a nice slice. Now we also need to add some boxes because we need to cut this down here and here because we only want this piece really. So I'm going to do that. So I'm just going to paste these boxes in, and these have to be we want that's okay. Let's look at that. So we're going to use these to subtract these pieces. So that's, I mean, that could go along. It doesn't matter because this part's going to be obscured by the wheel of the bike. So it doesn't matter whereabouts this is. It's just going to cut this edge off, which is what we want. So we need to use difference now. Difference. Let's take a look at that. Right. So now we're going to add another box to extend our light trail out. That Close here. Okay, that's good. There needs to be a gradient on this, and I also need to join all these pieces together, so we're going to add a union. So let's go here, union, close that bracket. Let's just check that. Okay, so what we're going to do is inside here, this is where we add our colour information. Remember, if you've coloured your objects here with the pigment function, you're not going to get any change when you put something in here. Now here we're going to use a gradient. So to do this, you use the command texture as usual, and then pigment, and then instead of where we normally write colour, we type gradient, and we want our gradient to be along the x-axis, so we put gradient x in. And then what we do is we use a function called colour map, colour underscore map, and then we open parentheses there, or curly brackets. And now what we do is we write a series of values here which represent our gradient, starting at 0, and then we can go up to 1. And you do this by using square brackets. So at point 0, which is where the thing starts, I'm going to use colour white. And then we close that, and then we open up another one, 0.55, so just over halfway. It's going to blend. We're going to keep it at white because we don't want it to turn to a different colour just yet. And then 3/4 of the way along, 0.75, we're going to go colour, and we're going to use LC main, and then close that. And then finally, right at the end, I'm going to add 1 and do colour LC main again, just to make sure it's solid at the end. Okay, so let's have a quick look at that. Actually, I don't want that there. Let's run that. No, I do. What am I missing? Here we need another one for the texture. Okay, run. That's it. Now, I need to stretch this out because the as you can see, we're getting a repeat. So I'm going to add a scale in, and we'll do it just here, scale, and we'll go 5 on the X, 1. Let's look at that. Okay, so that stretches it out so that it takes longer to go from 0 to 1, because it's going to cycle, because it's as it goes through, depending on the length of the object. So if I make it longer, it takes longer to get from 0 to 1. So we get the correct scale there. Now I also want to add some other stuff to this. So if I type finish in, and then open brackets, I'm going to use ambient, because I want this to glow. So I'm going to put ambient RGB, .5, 2.5, 2.5. This will make it glow bright. And then we close that off. Oops. Run. So you can see that's lit up nicely. So let's bring back everything. So let's find, where did I put the thing? There it is. Let's get rid of that. And then at the top, get rid of that. Let's run it. Okay, so that's looking fairly good, but it's a bit too bright. So what I'd like to do is change the ambience of the scene. I don't want this to be as bright, and then it'll tone this down as well. So in the global settings that we have at the top, I'm going to add ambient light RGB, and then in angle brackets 0.1, 0.1, 0.1. Now if we run this, you can see that brings it back down, and we get nice dark shadows as well now. So we're a bit short on this, so we're going to add a little extension onto the end of our trail. So I'm just going to paste this in. It's just a box with the things applied as before. I'm going to just change that to LC main so it updates if I was to change it. Okay. I need an extra curly bracket at the end. Okay, we're going to work on the floor now. You can see that goes all the way to the edge. Right, let's work on the floor. So a new section, call it ground. We're going to use a plane. Planes in POV-Ray are infinite, and you just have to describe where the normal is and how high up it is, or how far along that normal is. So we can just type in plane, open our curly brackets. We want this to be flat on the ground, which is Y up. So 0, we want it to be at 0 height as well, so it's Y and then 0. Now we're going to add a texture to this. Pigment. And we're going to use a procedural texture called brick. So we type brick, color, RGB, 0.9, 0.9, 0.9, and then color RGB 0.01, 0.015. So that gives us like the colours of the line, and which is that one, and then the colour of the bits that aren't the line. So if we just I need one more. Let's just look at that quick. So we're getting there, but it's the wrong size, so we need to scale this. So let's do that. I'm going to scale it down by 0.4. Okay, that's looking good. So I'd like to animate this, and one way to do it is to have the floor move. So we're going to do that, and to animate things in POV-Ray you use something called clock. So when you set off a render, the first frame has a clock value of 0 and the final frame has a clock value of 1. So it's possible to use that number to drive various parameters. And I'm going to drive the position of this gradient, not gradient, brick texture. So I'm going to put translating, and we're going to have a value of, what was it? It's something to mess around with to get it how you want it to look. I'm going to use 3.2 times 2 times clock 0,0. Now this is to do with the distance between these, because I want this to move one grid each time, each tick. So I found out that length is 3.2, and then I've multiplied it by 2 because the clock is going from 0 to 1. I want it to move faster than that, so I multiplied it by 2, and then I've put this clock variable in. Well, it's not really a variable, it's just a thing that comes out of POV-Ray. And if I run that, it doesn't animate because we've got to do something else before we can see the animation. So let's close that down. So what you do is you start a new file, and we go insert animation and animation 1 INI. So what we need to do here is put in stuff that we need here, which is we need the input file name. So we need the file name of our file that we want to render, which is Tron cycle new.pov, and I also want the to change some of these settings. I want the initial frame to be 1 but the final frame to be 12. We don't need to change any of the other things. So if we run this, instead of running our POV file, we run this ini file, and it asks us to save it. So we're going to call this, I'll just call it Tron cycle new animate. We'll replace the old one, and now you can see that it's actually rendering the animation. So before I finish, I want to add some more things to this, and the thing that I noticed on the original Tron film is that they've, to make this look less static, they've made this sort of triangle flash thing, flash on and off here. So we're going to build that, and to do that, we're going to have some more geometry. So let's bring in from my pre-made file the geometry we need, and I'm going to talk a bit about how we animate this, and there may be better ways to do this, but this worked for me. So intersection, union, difference, we know what that is. Sphere, box. We're basically creating this wedge thing that's going to appear on the thing there, like that. But we want to animate this on and off. I suppose I could do it by animating the colour, but I did it by animating the scale, and I used the mod function, which is modulo. And you've probably seen that in other uses in computer graphics and lots of other things. It's basically when you do something, mod something, it returns a remainder. Now, what I'm going to do is use if, else and end. So I'm putting in mod whatever the clock is times 48. Now you need to adjust these values to get the right sort of flash that you want, and then I want to do divide it by 2, or do modulo 2. So you put mod clock 48 times 48, and then the second number is what it's dividing it by, and I want to see when the when that's 0, when the remainder is 0. So if, so we're using if and else statements, and you probably seen these in programming as well. So it's if this is true, do this, else do this. So I've put in scale 1, 1, 1, and then 0, 1.005, so it sticks out a little bit, and then if it's not 0, it's shrunk to 0. Sorry, let's explain that again. If the result of the mod with the clock is 0, it does that, which scales it out a little bit. If it's not 0, it scales it into 0, so that you get nothing. So if I go to my animation thing and then run that, we can't see it because that's close. Let me just do that. Okay, there we can see it pops on and pops off again. On, off. So that gives us, if I go to my sequence inside my projects, That's the one we want. And if I play that, you can see we get something that looks quite nice. Now, you notice we've only got one at the front, we haven't got one at the back. And I don't really want to recreate that whole thing, so what I'm going to do is do a declare. So we go back into our file. Let's just close that. Go into our POV file, and I'm going to declare this. So let's just call this wheel flash, and then we'll declare wheel flash equals object, open brackets, close bracket. Let's look at that. Oops, no, I don't need that. Yeah, I need a curly bracket, don't I? Right, there we go. So that's gone now. So remember that we have to, when we've declared an object, we have to then invoke that object to see it. So I'm going to just bring that in, and I'm going to do a second one. I'm going to translate 2.5 units along so it fits the other wheel, and scale it down so that it's flush with the side of that wheel. So if we look at that, you can see we get that effect. And if I run my animation, you can see how that works. Don't need to reload. Oops. There we go. So that's how I did the Tron cycle. I hope you've enjoyed watching this. It's certainly fun to mess around with these old techniques. Maybe you can come up with something better than this and do something that works even better. Maybe you can have curves that it follows and stuff. There is ways to do that, but I didn't want to go too complicated in this. So thank you for watching. Goodbye.